Assalamualaikum and good day. Now we continue with the Coulombs Law. Okay, the the force F between 2 point charges. Okay, let's say for these charges Q1 and charges Q2 is directly proportional to the magnitude of the charge and inversely proportional to the square distance between them. So remember there is a square, and this is the proportional relationship, okay, between them, between the force and the 2 point charges, and we make into equation, we will introduce a constant. Okay, the force at position Q2 here is the vector force 2 acted upon at charge Q2 is equivalent to K Q1 Q2 over R from 1 to 2 with square here, okay, missing, sorry, and in the direction of unit vector from 1 to 2. Okay, you see here is the vector F2 and here is the direction, okay, for the force, okay, acted upon at position Q2. Force in Coulomb law states that force is mutual. The two charges experience the same force but in opposite direction. Coulomb's law is linear. If charge is n times larger, the force will be as well n times larger too. The force on charge is the summation of all of force acting on it. So F total is equal to the summation of all force acting on it. Electric field intensity, force at Qt is Ft, and the force at Qt over the total charge at the total charge of Qt is actually Ft over Qt. This is the intensity of electric charge at position Qt here. So you will obtain E, which is Ft over Qt, and you obtain this. Don't worry, I will provide separate lecture on how we actually obtain this F and E for your easy understanding. This is electricity due to the point charge. The total field at point due to many point charges, and the total field at a point, okay, because a point, so it is only a plus, okay. Electric field due to the line charge, because it's a line charge, okay, it is continuous. Instead of having like a point where is a summation, this one is continuous. That's why we have to use integration, because this is a sampling, but if you want the summation of all the continuous charge, we have to use integration. For this case, that you guys have seen this before, rho L dl equals integration of this, you get the charge. Yes, we continue. So this one you have here, this is a point charge Q1 and this is a point charge Q2. So let's take the example here is the distance of 1 from 1 to 2. Okay, this is the distance, and let's say we use a medium, okay, of permittivity of free space. Okay, so for simplification, we will use permittivity of free space in few of the chapters before we proceed with the actual permittivity in a material for more practical cases. Okay, actually this one in separate problem you may use. this one. But for now, for simplicity, we use first the permittivity of free space. So this one is actually equals to 8.854 times 10 to the power of negative 12. And the units, you can find it yourself. Okay, electric constant. Okay, you can find it. It's meter power of minus 3, kilogram minus of 1, s power of 4, a squared. Okay. Okay, now we proceed. What is the force experienced at point Q2? Okay, so imagine here, then you have some force acting on Q2, you have F due to Q1. Okay, then force is proportionate to the total, to the multiplication of the charges involved, and it is inversely proportional to the square distance. In this case, is this. Okay, and make it into equation. Then you have Q1, Q2 over R1 squared. Because this is a vector, it needs to have a direction. So for here is the vector, and what is the vector here? We said A, R from 1 to 2. Unit vector. Unit vector is a vector with a magnitude of 1. Okay. Then we have another constant here is 4 pi epsilon naught. Okay. So if you see this one, this is actually your constant just now, where you have F equals to 1 over 4 pi epsilon naught Q1 Q2 R1 2 from 1 to point 2, and in the direction of unit vector R from 1 to 2. So this one is the constant K. Okay, so hope that's clear up. Okay, we will cover about the electric field intensity. Imagine there is a point charge here Q1 and there is a point charge here QT. Okay, this QT will experience a force due to Q1. So here is the direction or the force of T. Okay, there is something that experienced by the QT, which is the electric field intensity. So the electric field intensity we put in different color. Electric field intensity is a vector, so we have E vector A. So electric field intensity is actually a force acting on it over the charges of that, which is here in this case is QT. We know that by in the previous lecture, Ft is actually Q1 multiply with qt over 4 pi epsilon naught r1t, don't forget square, in the direction of r from 1 to t, okay, unit vector. And here you see qt, so I put different colors so for easy to see, over qt, okay. So you can actually cancel out this and this. You will end up with q1 over 4 pi epsilon naught r1t squared in the direction of r1t unit vector, okay. So the general formula for E is actually vector of E q1 over 4 pi epsilon naught r squared unit vector of A. There can be a lot more electric field intensity experienced by a point, for example for this point P, by multiple point charges. For example, you can imagine you have Q1 here, okay, then it acted upon Q at point P, then you will have electric field intensity E1. At this point, let's say you have point charge 2, P will experience electric field intensity from point charge 2 here, E2, okay. And for example, you have a lot of charge. For the next one, let's say is Qn, means more, and you can have more. Then P, at position P, you will have experience the electric field intensity of N. So the total charge, so the total electric field intensity here is, for example, in this case, you have K from 1 until N, where it is the summation of all the electric field intensity. Sorry, this is E. Okay. You notice this case is where the Q1, Q2, Q and Qn is a point charge. Okay. How about if it's continuous? If it's continuous, then it will have not a summation, but actually a continuous summation. Okay. So for example, if you have a line charge, and if you have a point here, let's say point P, okay, and you have a small charge here, I mean small sample of rho L, okay, then here will also exert an electric field intensity. Then you have, let's say, E1 here, and here you have E2. But because this is a very long line charge, continuous, so it is a where we want to tackle the electric field intensity, we must take into account this factor of a line charge. So for here, for this line charge, your E would be rho integration of L, rho L dl over 4 pi epsilon naught R2 of in direction of R unit vector. Okay. Thank you.